We are Cal Poly San Luis Obispo, and here is our build progress by subsystem for our STYX and stones prototype.
The frame is made from aluminum 1 and 1.5 inch square tubing with a wall thickness of a 16th inch, except for the diagonal members, which are an 1/8 inch thick. The frame is held together with 1/8 inch thick aluminum brackets and quarter 20 bolts for easy disassembly. We're using HG15 profile steel rails with linear bearings for tool translation in both the horizontal and vertical directions, and we're mounting to the test bed via aluminum angle brackets and 3/4 inch lag bolts at each corner.
For our drilling tool, we're using a Bosch rotary hammer with a 1.5 inch diameter masonry drill bit. In the test that you're seeing now, we drilled through 6 inches of dirt and sand and 4 inches of concrete to reach the ice beneath. Additionally, we manually toggled the forward and reverse mode on the drill. However, in future tests, we'll have a servo motor actuate this.
After drilling through 6 inches of sand with rocky inclusions, 4 inches of concrete, and 4 inches into the ice block, we removed the drill bit to prepare for the heater probe operation. Right now we do not have a lower collar which maintains the alignment of the drill bit. This will be implemented for testing by April 9.
In this clip we're actuating the Z-axis downwards with the gear motor, and we're sending the gear motor PWM signals. And we had difficulty drilling through the concrete at a set speed, so we used a pulsing method where we drilled for a short duration and then actuated downwards and drilled in place and repeated that.
In summary, it took about 5 minutes to get through 4 inches of concrete and about 3 minutes for 10 inches of ice.
In our control box, we currently have a power strip to branch power from the main 120 volt source, and we directly provide power to a 12 volt power supply, 5 volt power supply, and a microcontroller from it.
2 load cells attached to the drilling platform are used to collect the weight on bit in newtons.
To begin testing the heater probe, we created the first prototype using a 1 inch diameter copper pipe with a 200 watt cartridge heater at the tip. During the test shown, we only used about 100 watts to melt the ice since there were temperature sensitive wires. For the next test, we purchased a 250 watt cartridge heater with more resilient wiring to resolve this issue. In addition, our first prototype included the water jet powered by the same 12 volt peristaltic pump, which will be used on the final prototype. In this test, we evaluated the effectiveness of the water jet using water at 120 degrees Fahrenheit. For the second prototype, we mounted the rotor joint, the pump, the tank, and the heater probe to a temporary plate made out of plywood. In this case, we used manual switches to control the pump and the solenoid valves. We plan to implement relays for this operation by April 9. To finish up the test, we switched the valves so that the water enters the collection bucket. In this case, all the components worked as intended, although we observed frequent air pockets in the water line. We think this had to do with the suction holes on the auger surface being partially blocked by wiring inside. We will continue to test the prototype with debris and ice. We appreciate the opportunity to represent Cal Poly in this competition, and we look forward to your feedback.